Hi, welcome to video 9.8b, interval of convergence. We touched on that on the last problem in the last video. Okay, so now in 11 through 13, okay, now instead of saying find the radius of convergence, it says find the interval of convergence for the power series. Be sure to include a check for convergence at the endpoints. So you have to decide whether it's inclusive or not inclusive as far as you keep each or both of those endpoints. Okay, so this is like number 20. It's not quite number 20. You can see right now it's a power series because of the x. You can see because of the x minus 4, it's centered at 4. Okay, so we're going to do the ratio test. All our terms are non-zero. You're going to have the absolute value is going to make the negative 1 to the n disappear. You're going to have n plus 1 factorial, x minus 4 to the n plus 1 over 3 to the n plus 1. And then you're dividing by this, which means you're just going to multiply by the reciprocal. So that'll leave a 3 on the bottom. N plus 1 factorial is n plus 1 times n factorial, so the n factorials cancel, leaving you with just n plus 1. And these two things have the same base, subtract their exponents, and you'll have x minus 4 left at the top. So because this is the limit as n goes to factorial, I'm going to pull the absolute value, very important, of x minus 4 on the outside. What I have left on the inside is just n plus 1 over 3. This is actually a very interesting case because this limit, because the degree of the top is bigger than the degree of the bottom, will be infinity. So it's a very special case. This means that this limit is always going to be bigger than 1, which means the series is going to diverge for all values of x. Therefore, the radius of convergence is 0 because there is none, and there's no interval of convergence. Okay, so again, just as a reminder, when you're finding the radius of convergence, you'll use the ratio test and you'll isolate the absolute value. So if it's Maclaurin's, you'll get to the point where you have absolute value of x is less than r. R is your radius of convergence. If it's Taylor, you get to the point where you have absolute value of x minus a or x minus c, whatever you want to call it, is less than r. For interval, you'll do the same thing, but then so this will become x is between negative r and r, and then you got to decide which of these four it is by checking the endpoints. Same thing here. This becomes x minus a is between negative r and r, which means x is between negative r plus a and r plus a. Again, you're going to have to check the series of constant terms when you replace x by negative r and by r. For Maclaurin's, and for Taylor, same idea. You're going to have to replace x by negative r plus a and replace x by r plus a to see whether you get convergent or divergent series of constant terms, okay? So if the series of constant terms is convergent, you'll include the endpoint. If it's divergent, you will not. Okay, so this is number 14. That question is find the interval of convergence. Okay, so it is a power series. You can tell by the x. It's Maclaurin's because it's just plain old x. Your UNs are non-zero. You'll do your ratio test. Remember, the negative 1 to the power disappears because of the absolute value. So we have n plus 1 times x to the n plus 1 over our UN, which is n plus 1 times x to the n. This will become x on top. This is n goes to infinity. We pull the absolute value of x on the outside. We have the limit as n goes to infinity of n plus 2 over n plus 1, which of course degree of the top equals degree of the bottom is 1. So we're left with the absolute value of x. So by the ratio test, if this limit, which is the absolute value of x, is less than 1, the series converges. The 1 would be the radius of convergence, but that's not the question. Solve that absolute value inequality, you get x is between negative 1 and 1. The question is, which one of these four answers is it? And of course, that'll be answer A, answer B, answer C, answer D. So we're going to check. We're going to start with checking the negative 1. We're going to go back to our original function and replace the n by negative 1. Well, what happens is I have negative 1 to the n plus 1 times negative 1 to the n, which is negative 1 to the 2n plus 1, which is always odd, which means it'll always be negative. And therefore, by the nth term test, that series is divergent because the limit as n goes to infinity of this Vn is infinity. So we cannot include the negative 1. Then we check x equals 1. We replace the original x by 1. By the nth term test, again, it diverges. So the answer is we can't include either one of the endpoints. Okay, so this is just a reminder of the ratio test. Here's number 16, ratio test will eventually give you a 3x inside. You'll pull it out on the outside with the absolute value. What you'll end up with is 1 over and 2n plus 1 times 2n plus 2, which is this expression. Well, as n goes to infinity, since the degree of the top is less than the degree of the bottom, that'll be 0. So this is another special case, which means that'll be 0 for all x. So the series of convergent is convergent for all x, since that limit, which is 0, is always going to be less than 1. So we say the radius of convergence is infinity, and the interval of convergence goes from negative infinity to infinity. Here's like number 22. Again, this is a Taylor power series, right? We do our limit as n goes to infinity, absolute value n plus 1 over un. When you simplify, you'll pull out this absolute value of x minus 2. You'll be left with n plus 1 over 4 times n plus 2. Of course, degree of top equals degree of the bottom, so it's leading coefficient over leading coefficient, and we end up with that. Now you have to isolate your absolute value in order to get your radius of convergence. And then for your interval of convergence, you'll solve the inequality, the absolute value inequality. X minus 2 is between negative 4 and 4. You'll add 2. You end up, it's between negative 2 and 6. The question is, do I include the negative 2? Do I include the 6? So here's the check for the negative 2. You go back to the original function. If you replace x by negative 2, you'll get negative 4 to the n plus 1. That's negative 1 to the n plus 1 times 4 to the n plus 1. Those n plus 1s cancel. Alternating series test, and you'll find out that the series converges. So we get to keep the negative 2. As far as the 6, plug that into the original function. We get a harmonic, which is divergent. We do not get to keep the 6. So square bracket around the negative 2, parentheses around the 6. Here's just another example. Again, this is Taylor because of the x minus 5. Again, it's a power series. Ratio test. The negative 1 will disappear because of the absolute value. You'll be left with an x minus 5, which you'll pull out in absolute values. And here you'll be left with n over 5n plus 5. Degree of top equals degree of the bottom, leading coefficient over leading coefficient. So we know by the ratio test that if this limit is less than 1, the series converges. So if you isolate the absolute value, you'll get absolute values less than 5. That's the radius of convergence. For the interval of convergence, we're going to solve the absolute value inequality. We'll get x is between 0 and 10. We plug in 0 into the original function, so 0 minus 5 is negative 5, which we break up into negative 1 to the n times 5 to the n. That'll cancel with the 5 to the n on the bottom. This is negative 1. Oh, here we go. Which is negative 1 to the 2n plus n, which is odd, which means it'll always be negative. So I just pulled the negative on the outside. And that's negative 1 times the harmonic, which will be divergent. Then we tried 10. So 10 minus 5 is 5. Those cancel by the alternating series test. It converges. So we cannot keep the 0, which is why it's round parentheses, but we can keep the 10.